Alright class, welcome to this second video, second part of our week 3 discussion on roots and rational expressions with roots. Now we're going to talk about dividing radicals. Okay, so this is one of the trickier subjects with roots. So we want to look at simplifying more complicated looking equations like this, where we have a 4 minus root 12 over 4. So what our general procedure here is going to be to get this root value into sort of the minimal term possible. Okay, so if we had, so 12, for example, can be rewritten as 2 times 2 times 3. Well, we have this 2 times 2 in here inside of a square root, which allows us to pull that 2 outside of it, right? Because we can have, basically we have, we have the square root of 2 times the square root of 2 times the square root of 3. Well, what's the square root of 2 times the square root of 2? Is just equal to 2 itself, okay? Okay, so we've rewritten this. Now we can factor out a 2 out of everything up on top and rewrite this bottom 4 here as a 2 times 2. We'll cancel off these 2's. And we've simplified it now as 2 minus square root of 3 all over 2. Okay? So that's something you should get very used to. You'll do that a lot in this section, is looking at a value like this and getting it down into its smallest number of terms. So breaking it down into 2's and 3's to other non-divisible numbers. Okay? So good. Okay, so let's look at a more complicated example. We've got 2 plus square root of 3 over 4 minus square root of 3. Okay, so we've already got these square root of 3 terms in their minimal value. Okay, what we want to do here is get rid of the root in the denominator. So our general procedure here is going to be to remove this root in the denominator. So how do we do that? Well, it turns out if we multiply the top and the bottom, the numerator and the denominator, both by a 4 plus square root of 3, we'll get rid of the root in the denominator here. Okay, so we want to get rid of that. This is a general rule. What we want to do is multiply the top and the bottom by this numerator that we have here, but with an opposite sign here. Okay, so this will always work. So this is going to be your general procedure. Do some examples where you see this, but this is going to be our general process, is to do, if we have a 4 minus square root of 3, we'll multiply the top times 4 plus the top and bottom by 4 plus square root of 3. And as you do examples, you'll see why this works out. It allows us to, it's basically because of FOIL. When you're doing FOIL, any extra square root of 3 terms will cancel each other out. Okay? So you'll see that as you go through some examples. Okay, so multiplying the top and the bottom by this 4 plus square root of 3. You should all know how to FOIL this out at this point, but you see we're still left with this square root of 3 term on top, but it's gone away in the denominator here. So that's what we were looking for. Okay, which we can further simplify, adding like terms. We get 11 plus 6 square root of 3 all over 13, which can't be further simplified. Okay, maybe pause the video here. Make sure you can fill in the steps between here and there. Make sure that you see exactly what's going on there and why exactly we've done this. So when you work out that algebra, it should make sense to you. Okay, let's look at another example. Well, I'm sorry, I'm getting ahead of myself. So we want to now look at solving equations with roots. Okay, so remember, just like in every other example here, our golden rule for solving algebraic equations is that which we do to the left side, we must do to the right. Okay, and we can pretty much do anything as long as we do the same thing to the left and the right-hand side. Okay? So how does that help us? Let's look at an example like this, where we've got x cubed equals 27. We want to solve that for x. Okay? What we can do is take the cube root of both sides. So if we do that, take the cube root of both sides, again, we've done to the left side what we've done to the right-hand side. So this works. Okay, so we've got x cubed to the 1/3 power and 27 to the 1/3 power. We can rewrite that by using our rules for exponentials. We've got this x to the 3/3, which we can just cancel. That's just 1, right? And 27 to the 1/3 power, which you should have actually seen in the previous video, is equal to 3. And we see that x is equal to 3. Okay, so this is going to be our general procedure here. Is if you've got something like this, you can take the cube root or the fourth root or whatever to cancel the root on one side, so long as you do the same thing on the other side. Okay. Let's look at a more tricky example here. Okay, so we've got 2 times x minus 5 squared minus 7 equals 0. Now we're going to solve this for x. Okay, so I added 7 to both sides. Now I'll get rid of that 2 out in front by dividing both sides by 2. Now I've got this squared term up here. Okay, but this isn't like our previous examples where we've had x minus 5 squared. You can't, equals 0. If this was 0, we'd be able to stop and solve this really easily at this point. But because we have this 7/2 over here, we've still got to go a couple steps further. So now we'll take the square root of both sides. Okay, so if we were just doing this really quickly, we'd say, okay, now we've got x minus 5 on the left-hand side equals square root of 7/2. Now we'll add 5 to both sides. So we might think we're done at this point. But we're missing something here, okay? Let's look at an example like this. That x squared equals 4. Let's just blindly take the square root like we did the last time, where we would actually think, maybe we just end up with x plus 2, or x equals 2. But what we know is that minus 2 would actually work here as well. So minus 2 times minus 2, or minus 2 squared, gives us this same value back. Okay? So when we take the even root of something, we actually get a positive and a negative value. So here I've looked at it for x squared, but this same thing is true for x to the 4th, x to the 6th, x to the 8th, x to the 100th. This is always true. You end up with a positive and negative value like this, and we must include both of them. So this means we actually get 2 solutions here. Okay? The same thing isn't true of odd roots, but it is true for the even roots. Technically, it actually is true, but that's for a whole nother class. Okay, so let's revisit that previous problem we were doing, and specifically, we'll jump to the point where we made a mistake here. So we had x minus 5 squared equals 7/2. Now, when we take the square root of both sides, we have to make sure that we include the plus and the minus value here. Okay. And then we add 5 to both sides, so we've got 5, it looks a little bit ugly here, 5 plus and minus square root of 7/2. Let's get that into a cleaner looking form. 7/2, a square root of 7/2 can be rewritten as 14/4, square root of 14/4, which we can take the square root of 14 over the square root of 4. The square root of 4 is just 2. And now we can put this back into our equation here. So 5 can be rewritten as 10/2. So it's 10 plus or minus square root of 14 all over 2, which we can rewrite just to make it more clear as actually 2 solutions. 10 plus square root of 14/2 and 10 minus square root of 14/2. Okay? So just the trick to keep in mind here is that when you take a positive root of something, you always end up with a positive and a negative value here. And just like adding and subtracting, we can, as long as we do the same thing on the left-hand side as we do on the right-hand side, we can pretty much do whatever we want. So, you can use these root values to help you solve problems as well. Okay? Good job, and if you have any questions with any of this stuff, make sure you email me.